So data models, what are they and why are they important? Data models are frameworks that people use to design databases. And a schema is a plan for how to organize your data in terms of the data model. Data models and schemas are what enable you to structure your database in a meaningful way. The relational data model, specifically, is the most widely used data model today and will be the data model we follow for the majority of this course. The relational model says that you should define your organization in terms of relations, which are essentially tables that represent an entity or a relationship within the organization. And a schema is what describes these relations. So just some more vocab at the very bottom. A record is a single entry in a relation that corresponds to an entity. So going back to our university example, let's say we had our student relation. A record in that student relation would represent the data for a single student. Lastly, we have attributes. Attributes are columns in your relation that help describe each record. And in the relational model, an attribute consists of an identifier and a type. Okay, so I know I threw a lot of information at you, so let's bring things together by creating a schema for our university. So in our university schema, we need to lay out the blueprints for our entities, stuff like students, courses, and instructors, along with the relationships, so students enrolling in a course, instructors teaching a course. Let's cover the instructor entity first. So we'll represent instructor as a table called faculty. So to keep things simple, let's say that our faculty members have a name, a faculty ID, and a salary. Since we're following the relational model, all these fields must have a type associated with them. So let's go ahead and write down the information for faculty. So like we said, we're going to have a name, and we'll represent this as a string. Okay. Next up is the faculty ID. Which we'll represent as an integer. Please excuse my sloppy handwriting. I hope it gets the point across at least. And then finally we have salaries, which we will represent as a real number. Okay. Next, let's create the student relation. So our students will also have IDs and names, but will have a GPA field instead of a salary. So we'll add students. They'll have a name, and we'll represent name as a string as well. We'll add student ID. And we'll represent it as an integer. And lastly, we will add the GPA. Okay, so the last of our entities is course, which will give an ID, a name, and the number of credits it's worth. Alright, so now that we've finished our entities, let's create a relationship. We're not going to do all the relationships. I know I mentioned two, but let's just do one as an example. And we'll call this one enrolled, and we're going to model a student enrolling in a course. And so for this relation, we're going to aggregate information from both the students and the course's relations. So in this relation, each record will have an SID or a student ID along with a CID or a course ID, which tells us which student has enrolled in which course. And so alongside these attributes, we'll have the grade, which is just the grade that the student earned in that course. Alright, so now we have a pretty decent schema to describe the entities and relationships in our university. Obviously, there is a lot to be desired. We could add some more relationships, we could add some more attributes to our existing relations, but hopefully this gives you a feel for how relations are designed. And as you can probably tell, schemas are extremely important. After all, schemas allow you to bring your ideas for your database to life. So let's get into the different types of schemas and how they work together to describe your data. Okay, so let's start with the conceptual schema, right here in the middle. The conceptual schema defines the logical structure of the database. It describes your database in terms of the DBMS's data model using entities and relationships. And this might sound kind of familiar because the example schema that we just developed for our university was actually a conceptual schema with the entities described here and some relationships here. So moving down towards the hardware, the physical schema describes how the relations from your conceptual schema are stored on disk and how records are retrieved. You can use indexes to speed up certain operations, and we'll actually talk more about indexes later in this course. An example of a physical schema design decision would be choosing to store relations as unsorted files of records. So what does this mean? Well, again, a relation is basically just a table, so if you're storing a relation as an unsorted file of records, that means each row of information, or each record, is going to be unsorted. And this is going to impact certain operations differently than, for example, storing relations as sorted files of records. With sorted files, inserting now takes longer, but maybe search time is decreased. And so your schema specification largely depends on which operations you want to optimize. Maybe you search much more often than you insert records, or vice versa. Okay, so let's move all the way up to the top and talk about the external schema. The external schema is a collection of views into the relations of a database. What are views? Well, here we can see views describe how different users see the data, but more specifically, a view is a way for the DBMS to give certain user groups access to curated portions of information. Let's use our university example. So let's say we wanted to give students a way to look at course information. So this would be stuff like maybe the ID of the course, the name of the course, along with the name of the faculty member who teaches the course. Well, you can save these students time by creating a customized view of the courses and faculty relations, because you know that they're going to be accessing this specific information. But at the same time, you don't want to give students privileged info like instructor salary, so you can pick and choose which attributes from the faculty relation to put into your view. So as you can see, views are great because you can give user groups information that is relevant to them, and at the same time protect your sensitive data from those who should not have access. The data definition language, or DDL, is what defines the conceptual and external schemas. That is, the DDL provides us the syntax and logic to implement these schemas according to our data model. When making updates to the database, you can use the data manipulation language, or DML, to access and update your data. The data querying language is a sublanguage of the DML that you use specifically for querying your database. And when I say sublanguage, I mean that the DQL is essentially a part of the DML. And again, these sublanguages have their entire own syntax that you use to implement your desired functionality.